I am certain that you know that angles are formed when two lines meet. Abam knows this too. He saw it in a textbook while reading about angles. He was thrilled to learn about the types of angles. He wondered why some angles were acute. He knew that acute illnesses were quite serious, but why were some angles called acute? He found out that acute was gotten from the Latin words acus, which meant needle, and acuere, which meant to sharpen. So the angles that somewhat looked like sharp needles were called acute. Cool! He tried to remember places where he saw acute angles. He quickly remembered a slice of pizza, an ice cream cone, and the party hats made during his last birthday anniversary. The acute angle is greater than 0, but less than 90 degrees. There were other types of angles in the textbook. They include the right angle, the obtuse angle, and the reflex angle. The right angle is an angle which is exactly 90 degrees. Abam thought of an example and remembered that the wall of the room met at 90 degrees with the ground level. Even the edges of the book he was reading met at 90 degrees. The next angle is the obtuse angle, which is greater than 90 degrees and less than 180 degrees. An example is this beach bed. The final one is the reflex angle. It is greater than 180 degrees but less than 360 degrees. It is usually outside like pizza when one slice is taken away. Thank you, Abam, for your findings. We will use Abam's findings to learn more about positive and negative angles. We will find the sine, cosine, and tangent of acute angles. In our earlier lessons on trigonometry, we learned how positive and negative angles are formed using anti-clockwise rotation. So let's form a positive angle. Remember, we make use of the x and y axis for easier reference. Let's draw a positive acute angle beginning from the horizontal line OX. Joining point A to the horizontal line, we have a right angle. We know from the basic trigonometric ratios that sine theta is equal to the opposite over the hypotenuse, which is AX over OA. Cos theta is adjacent over the hypotenuse, which is OX over OA. And tan theta is the opposite over adjacent, and this is equal to AX over OX. To remember the values of these ratios, we use SOHCAHTOA. We have seen the sine, cosine, and tangent of acute angles in this lesson. We will be moving to the sine, cosine, and tangent of obtuse and reflex angles in subsequent lessons. See you there.